So our first step of our next problem is to define your variables. So let x equal and y equal something. So when I read this for the first time, I'm trying to figure out what are the two things I'm going to be looking for. You are selling tickets to a fundraising dinner. Adults pay $15 each and children pay $10 each. Those are two things, so that might be, we're talking about adults and children maybe. Let's keep reading. If the number of adult tickets sold is twice the number of children's tickets sold, again, children and adult tickets, the total income is $1,600. How many of each type did you sell? And the really big key here is how many of each type. So what are the x and y? The types of tickets. So the x is going to be the number of adult tickets, and y will be the number of child tickets. Okay, so now we're going to go back and read again. We know we have a money equation because I remember hearing $15, $10, $1,600. So let's see if we can find those pieces of information. We have $15 for adults, children pay $10 each, and we have a total income. So all of those are money. So all of those are going to go in the same equation. $15 for every X ticket, so that's 15 times X, plus $10 for every Y ticket, so that's 10Y, equals the total number, which is 1,600. So that's going to be one equation. Now the other equation, we are talking about the number of tickets. So let's keep reading. You are selling tickets to a number of fundraisers. Okay, so that's the first sentence doesn't help. Adults pay 15 and children pay 10. Well, that already is used up. The next sentence, if the number of adult tickets is sold is twice the number of children's tickets sold. So that right there is a comparative statement. We're comparing the number of adult tickets sold to the number of children's tickets sold. So we can write an equation for that. The number of adult tickets is X. Is, do you remember what is means? Is means equals twice the number of children's tickets. Twice means 2 times the number of children's, which is Y. So 2 times Y. Keep reading, and then the total is 1,600. We already used that piece of information, and we've used everything else. And now this is the two equations. This type of equations are really nicely set up for substitution. Do you see how here the x is already isolated? And so all I have to do is take what x is equal to and substitute it in for the variable in the first equation. So that would be a substitution method. So I'm going to start by writing out the red equation. 15x, but instead of x, I'm going to put a parentheses, plus 10 times y equals 1,600. But I'm going to take what x is equal to, and I'm plugging that in for x, right? So I'm going to take x out and replace it with 2y. Now I only have one equation with one letter y. So I multiply, I get 30y plus 10y equals 1,600. These are on the same side, so I simply add them together by combining like terms. That's 40y. And then I divide both sides by 40. This leaves me with y is equal to, the zeros divide out, 160 divided by 4 is 40. So what was y again? Oh yeah, y was child tickets. So apparently we have 40 child tickets. How do I find out what x is? Well, one easy way to find out what x is I just take one of the two equations. I think the green equation is a little easier because it's already solved for x. So in green I'm going to write x is equal to 2 times y. But what is y? We already know y is 40. So that means x is equal to 2 times 40, which is 80. So apparently the adult tickets is 80. So when I write my answer, I'm going to write 80 adult tickets and 40 child tickets. This is what I believe my answer to be. In order to check, I could always go back and reread the whole problem. You are selling tickets to the fundraising dinner, okay. Adults pay 15. So if I have adults paying 15, let me get my calculator out. So if I take 80 times the $15 per ticket, so 80 times 15, that's 1,200, and I have 40 child tickets, but they only cost $10 each, so 40 times 10, That's going to be 400, and if I add those up, does that get me 1,600? Yes, it does. So the money checks out. Let's see. Is the number of adult tickets sold twice the number of children's? 80 is twice as much as 40. So just by reading the word problem, I was able to check my work. Our next problem, we're planning a trip to Washington, D.C. And New York City. The travel agency quotes you the following price packages, which include food, hotel, and rental car. What is the average cost per city per day? Okay, so this question right there, what is the average cost per city per day? That's going to tell me what my x and y are. So I'm going to let x equal the average cost of New York City per day. And so y is going to be the average daily cost of Washington, D.C. Again, per day. Okay, so in package 1 we have 2 days in New York City and 3 days in D.C. and that costs us $2,484. And package B has 4 days in New York City, 2 days in D.C. costing $3,120. So I'm going to have two equations. I'm going to have an equation for package A and I'm going to have an equation for package B. So for package A, I'm going to do in purple here. I have 2 days in New York City, so that's 2 times the average cost per day, that's 2 times x, plus I have 3 days in DC, so that's going to be 3y, and it's going to equal 2,484. In package B, I have 4 days in New York City, plus 2 days in Washington, D.C., and that adds up to 3,120. So I take 4 times the x, which is the average cost per day, in New York, plus 2 times y, which is the average cost per day in DC, and that should add up to my total. So this is my equation. Because these x's and y's are all lined up nicely, this definitely looks like a elimination problem to me. I would like to eliminate, either one is probably okay, but I'm thinking the 2x and the 4x are smaller, so let's try that one. So the least common multiple between 2 and 4 is 4. Because 4 can be divided by 4 and 4 can be divided by 2. I want one of the equations to be equal to a positive 4, which b is already a positive 4x. So let's make the other one equal to a negative 4. So if I multiply by negative 2, that gets me a negative 4. So negative 2 times negative 2 is negative 4x. Negative 2 times 3 is negative 6y. And negative 2 times 2,484 is, let's do that in our calculator, 2,484 times 2 is negative, because I forgot to multiply by negative 2, negative 4,968. The B equation already has a positive 4, so I'm just going to go ahead and write that right underneath, so that when I add the equations together, the minus 4x and add 4x add to 0. Negative 6y plus 2y is negative 4y. And let's see, negative 4,968 plus 3,120 gets negative 1848. Now I can divide both sides by negative 4. And that gets me y is equal to 462. What was that? Y again? Oh, right, that was the average daily cost in DC. It's $462. All right, next I have to find out what y is. I'm going to choose either the blue, either of the two formulas. So I'll choose the purple one. 2 times x plus 3 times 462 is equal to 2,484. So 462 times 3 is 1386. So I'm going to take minus 1386 on both sides, which is going to leave me with 2x is equal to 2484 minus 1386. Oops, try that again. 1386 is 1098. Now I'm going to divide both of those by 2, and that gets me x is equal to 549. So we have 549, which is the average cost per day in New York. So I'll summarize my answers. So we'll say 462 is our daily rate in DC, and we have 549 is our daily rate in New York City, and that is going to be our answers. And if I want to, I can go back and check my work. I'm going to go ahead and just type it straight in the calculator because these numbers are large. So we have 2 times 549 plus 3 times 462, and that should equal 2484. It does. All right, let's try the next one. 4 times 549 plus 2 times 462, and that should equal 3,120, and it does. So this does check out, and I have completed this word problem.